Hi, Algebra 2. We are going to start on our notes for today. Hopefully, everybody has them out and ready to go. We are expanding on what we've been talking about the last couple of days on your central limit theorem. And we're going to discuss margin of error, which you might have heard before, and confidence intervals. So let's start with a definition of margin of error. Margin of error gives a margin on how much the response of a sample would differ from the responses of a population. So all that is saying is what's the difference between the population mean versus the sample mean? How much is a difference would there be if we had this data? Would it be a huge? Would it be a little bit of margin of error? Would it be a lot? So here's a formula that we need to know, and this is MOE, is just an abbreviation for margin of error. And it says it's equal to plus or minus. Why is it plus or minus? Because if we have a z-score, then we have it going in one direction from the center, a 0, and to the other one. So that's why we have plus or minus. So you plus or minus your z value times. Do you guys remember, does this look familiar? Hopefully it does. This is your sample standard deviation. So you're multiplying your z-score times your sample deviation. Okay, so if the percent of the sample responses is your average, your mean, then the percent of the population would respond the same way is between your mean minus your margin of error and your mean plus your margin of error. So we'll talk about that more in just a minute. So imagine a polling organization that surveys 1,000 voters in a city to find out how they plan to vote in the upcoming election. The organization reports that 58% of the city plans to vote for Smith and that the survey has a margin of error of plus or minus 3%. So find the margin of error. So basically saying that 58% plan to vote for Smith. The margin of error is 3%. So what do we think that means? Well, that would mean that 58% want to vote, and then you have your plus or minus 3. So then we would have 55% if you would have done the 58 minus 3, and then you would have 61% if you did the 58 plus 3. So we like to write this in interval notation because it is an interval. That's why it says find the interval. So we're going to write this as just like we do with all of our interval notation. Your smallest number comes first. So we would say 55% to 61%. And that's how you find your margin of error. And that's how you find your interval once you're given your mean plus your margin of error. Okay, so now let's talk about our confidence intervals. So we're going to go back to when we were using our central limit theorem, and we can construct an interval that estimates the population mean with a certain level of confidence, saying that it is going to be our population mean will probably fit somewhere within our confidence interval. So let's dive into that a little bit more. So let's look at this one. Let's first say, look at a 95% confidence interval. Well, we know 95% falls into the first 2 standard deviations pretty much. But if you were to go to plug this into your calculator and you were to find your z-score, and remember when we have the area under the curve, we actually can do the inverse norm with that. Well, you would see that it was not exactly 2, but it would be between negative 1.96 and positive 1.96. So then we can also know that when we have relatively large sample sizes, that the sample means are normally distributed. Remember, we said that the mean of your average samples is going to be equal to your population mean. And the standard deviation formula, which we've talked about before, is it says the standard deviation of your sample is equal to the population standard deviation divided by the square root of n, and n is our number of trials. This can also be called the standard error formula, kind of going with your margin of error, but this is your standard of error. So what does this all mean? It says, so there's a 95% chance that the sample will have a mean somewhere between our population mean minus 1.96 and our sample mean plus 1.96 times our sample standard deviations. Okay, let's get into actual problems and then you'll see this a little bit more. Okay, so what is a confidence interval? It's a range of values based on a sample that we can say the population mean will fall somewhere within that given percent of certainty. So the correct mean will be captured in somewhere in that percent of the sample intervals. So to do that, we are going to be given this confidence intervals. So I'm going to, on your test, and this is something that I'm going to give you a note card for your final, possibly. Don't quote me on that yet. But your confidence intervals are going to be somewhere here, and you'll be given these z-scores. So you need to have a z-score has to be associated with your confidence intervals. So again, your formula that you need to start getting used to is this one right here. Is your sample mean plus or minus your z-value, which will be given depending on what your confidence interval is, times your sample standard deviation. All right, so let's get into a problem. Flip over. Say, a company produces white bread and is concerned about the distribution of the amount of sodium in its bread. The company takes a simple random sample of 100 slices. So what does that 100 stand for? Well, that would be our n, right? So n equals 100. Okay, and computes the sample mean. So here we go again with sample mean. So that would be our mu x bar is equal to 103 milligrams of sodium per slice, and the standard deviation will be 10 milligrams. So that standard deviation is going to be our sample standard deviation of 10 milligrams. Okay, so given a 99% confidence. So I'm going to go back here, and I'm going to grab our little, sorry guys, bear with me just a second. I'm going to go grab our confidence intervals. I'm going to copy, take your screenshot. That sounds great. Copy. Let's see if this works. So now it should be where it's on this page. All right, let's try not to cover up anything. Okay, so our 99% confidence. So what z-score is associated with 99%? Well, let's come down here and we see that 99 and we have that 2.575. So then our margin of error says, remember our formula, it says that it's plus or minus. So we're just finding out our margin of error before we're even adding it or subtracting it from our mean. That's where our confidence interval comes from. So we get the 2.575 and we multiply that by your sample standard deviation divided by your square root of n, which is 103. So our formula should really say that this is our, because that's how we're finding it, is our population mean. But that's what we're trying to find, and we're estimating our population mean. So we're really looking for, this is your sample and mean, and this is your, oh goodness, we need it, that should be 100. Too big. 100. Okay, so now we have plus or minus 2.575 divided by, or multiplied by 10 over 10, which is just 1. So we get, ironically, plus or minus 2.575, and that is your margin of error. So now it says, what's the confidence interval? Well, that's where you come in with your mean. So we've got to do our sample mean, and our sample mean is 103 plus or minus our margin of error. Well, what did we say our margin of error is? We said it was 2.575. So do that in your calculators. And when you do that, hopefully you will get an interval of 100.43 and 105.58. So that is your range. We are saying that we are 99% confident that our mean, our population mean, is going to be somewhere between 100.43 and 105.58. So that's the whole idea of a confidence interval. That's the whole idea of where your margin of error. It gives you some room for error. Okay, example 3. Let's look at this one. A sample of 100 observations are collected and yields a mean of 75 and a standard deviation of 8. Find a 95% confidence interval for the true population average. Okay, so here is the same thing. We're going to figure out, we want to know our N. What is our N? Well, our N should be 100. What is your mean? Your sample mean is 75. And your standard deviation, 8. And our confidence interval, we said, is 95%. Well, 95% confidence interval, go back up to our chart, 95% right here, and it says 1.96. So then our confidence value is 1.96. Now we can figure out what is our interval, our range for our mean. So same thing that we've been doing. We have 75 plus or minus your z-score, which our z-value is 1.96, times a sample mean divided by standard deviations. And we'll talk about why that changes on Monday, because if you go back to your formula, let's look at our formula. We're used to having the formula of u sub x bar is equal to population mean divided by standard deviation of n. So we'll talk about that more on Monday, why that switches up. I'm going to leave that for when I'm actually in the classroom. Okay, so we get 75 plus or minus. Do that in your calculator. When I did it, I ended up getting, let's see, you can do that all in your calculator at one time. I got an interval of 73.432 to 76.568. And you guys, we can check our work in our calculators. But that's what I got. Hopefully that is right. Okay, so we can say that we are 95% confident that our population mean will be somewhere between this interval of 73.432 and 76.568. All right, so let's see what this says. Is this the same stuff that we've been doing? Okay, so on this one, it gives you all of the samples that it says the SAT scores are normally distributed with a mean of 1,000 and a standard deviation of 120. Mr. Markley's calculus students earned the score shown below. So because it says that it has this mean normally distributed, so we can assume that, can we assume that the mean of this and the mean of the sample are the same? Maybe, but the thing is here is we have the samples. So we can actually find out what the sample mean is. So if you do that, I ended up plug that into your calculator. I got the sample mean is actually 108.4.38. So real close, but not exactly. But because we have the samples, we have all of them, let's go ahead and calculate it. So now we want to find the 99% confidence interval to estimate the population mean. So I'm just going to quickly do this one because I think you're probably getting the hang of it. 1,000 plus or minus the z-score of 99 is 2.575 times 120 divided by square root of 16. So then that's divided by 4. So when I did this, I got an interval of 922.5 and 1077.2.